Welcome to the 9th lecture. Too loud. The 9th lecture in software architecture. I tried to attract more students by having the red carpet installed, but it didn't help. I guess it was not properly announced. Anyway, the recording will be available, as all of them, probably. If it doesn't fail, if it fails, still we have the last year's recording, and it seems it is also in English. But I think I have one more in Slovak. Anyway, if any things would be unclear, I can explain them during these. Actually, we have one occasion on December 12th where we can get back to anything that was presented here and discuss anything we like. So we are here. So this is a 9th lecture, and the last one, I guess, that will be dealing with Bushman's patterns to some extent, or some patterns at all, like in design patterns. Well, actually, I'm not right, because in aspect-oriented modularization, I'll mention maybe some aspect-oriented patterns again. So, but then we will have next time this guest lecture, container-oriented software architecture and its implications, and that's roughly it. So we're here in maintaining software architecture. Do we need to go back to anything from our last meeting? So, when we develop software, maybe you do not think very much what's going to change in it. The question is, when it actually happens, when the need for a change becomes apparent. Is it like you develop some software system and you deliver it, and then, I don't know, in what time? In some weeks, months, years? What do you think? Or what is your experience? My experience is it happens within seconds. The moment that you deploy some system, you become aware that something is wrong in some part of the system, and then you pray that no one figures this out before you would have a chance to repair this. It happens with anything you write, actually. When you write some text, it doesn't matter. It doesn't have to be program code. The moment that you think you're through and you can submit it, and yet worse, you submit it and you cannot reverse this or submit another version, you spot the problem. That's the curse of writing. Probably it goes with other things that a man does, but this is so apparent with writing. So it goes, and then what happens? What opens is a huge phase of maintenance. So maintenance. What does it actually mean to maintain a system? I keep asking questions. Luckily enough, I'm also trying to answer them, but if you have some other opinion, go on. Or can you help me with this? What happened? What does it mean to maintain a system? I have some ideas, but I'm not sure about it or about them. What do you typically do when you maintain a system? Try to correct? What? Bugs. I was thinking about code base, so I heard you're saying base, so I thought maybe it's code base. Yes, it also might be, a whole code base might be flawed. It's yet another issue. So you correct bugs. That's the first thing. Actually, I was trying to. That was what I was mentioning. As soon as you deploy some system, you encounter some bugs there. Bugs mean that there are these are flaws in functionality. Some bad things, bad behavior of the system. The system should not behave like that, and you need to correct this. So these are apparent things. So you can see them, like by running the system. You can see some things are wrong. What else can be there in maintenance? So you say you can proactively look for bugs. So it's not that you become surprised and you try to hide them until you correct them, but you actually try. You're testing your system actively, looking for further bugs. Further bugs. What else? There are still we are with bugs. Will your user be satisfied by your system? Yes? Updates. Updates are not necessarily corrections of bugs. You may improve some things. Maybe even trivial or small things like some colors that you think would fit better. Newer version of what? Of the tools that you're using. Maybe you deploy even newer versions of some frameworks your system relies upon, something like that. That in turn actually may they may have improved behavior. Improve clarity of of graphical user interface controls or some things like that that just happen out of the box that work without you having to make any changes in your code even. But there might be some also user requests, change requests. Some small things or some bigger things. Still we are with functionality. So these are things that are like we don't expect a user to come and tell you, oh, you know what, that one class that I saw is somehow too big. They typically do not look into the code. They look how the system works and what it does and whether it does well or not. So, but that's something that you can see, and your colleagues and some code reviewers that you might engage. And you might start improving your code base, not bugs, for the sole purpose of improving it without changing the functionality. No, I don't have it here. I thought I was expecting refactoring to appear here. Refactoring, what I don't have in slides. All right, here. Well, can be read, but this activity is called refactoring. So you actually somehow restructure, reorganize your code. You might even add some things there, but not for the sake of changing the behavior. The behavior should remain the same. However, when you're improving how your code is organized and you see that some things could look better, so then you can combine the two, and we often do these things. So it might be like that some people, when you say refactoring also, well, I was doing refactoring and then I improved this menu. But this is not the purpose of refactoring. The refactoring process is about changing code so that it is more readable, more comprehensible, more easily maintainable. So when they ask you for changes, so that you can do them in a shorter time, and maybe that you can even reuse some parts of your system better. So this is related all about with the things that will come. But first of all, I'd like to remind you that we talked about this strategy of not pushing but pulling out what the user wants and then implementing what is needed. So not thinking of too much of things or assuming too much that will be needed, but reacting on the demand. And what goes hand in hand with this is to avoid producing waste. So these two things. So this pull don't push is more related to end users and how we respond to what end users want. While avoiding producing waste is related to making decisions at the most, or the should have been in parentheses as well, the most responsible at or no, it was good, like make decisions at the responsible moment. Some say the most responsible moment. I'm reluctant to put it like this with this, the most responsible moment, because how do you know whether the most responsible moment has come? So maybe you will be waiting too long, and you will miss the responsible moment, and you will miss the last chance to make some decisions, and then you will not be able to make those decisions anymore because the circumstances will change. So if you make decisions earlier, you might be pushing things forward, because you will be making up things that nobody wants, or the moment to decide about them hasn't yet come, and you decided to do I don't know how many additional controls in your graphical user interface for some reason, or some new version, some additional with some additional capabilities, but nobody raised this. Nobody wants this, and it's not clear whether this is necessary or not. Or when you produce this, then some other requests might come that will contradict your decisions that you made, because you did not have enough information, so you made them in advance. You're like cautious. You were preparing for just let's do this and do that because they might need it, and in turn you produce waste. So we don't want this. We want to be lean, like not to waste things, like being on lean budget. You don't have enough funds to spend on foolish things or unneeded things. Anyway, if we want to act like this when developing software, somebody could say, okay, this is a strategy, so let's do it like this. Let's start. Tell me what you want, and I'm not going to do anything until you tell me what you want, because I'm acting. I don't want to produce waste. But in the end, if you do not develop the basis of your system, then you will be forced to act once like that, once like the other way, based on ever-changing mind of your client, of your end users, and who knows who. So there you need some basis, something you can rely upon, some kind of order, some kind of architecture, but not too much of it, only as much as necessary. And this kind of architecture is called, or being denoted as lean architecture. Many things, when you think of these things about, and this is actually, these wise things come much that I learned come from the book that is actually called Lean Architecture by Koplin and Bjorvig. So Dean Koplin presented these things and presents these things, talks about these things wherever he can. And much of these things are not like use this framework, use this tool, use this notation, if you use UML, you are safe. It's not like that. It seems that it's just a way that we decide simply how we decide to act. What is our position? And those other things that seem so complex and so important, and they are actually important. It is important what framework you will use and how does it look like, and what are the capabilities. And it is important to be fluent in programming languages and in modeling languages and all those things. And it is important to be comfortable in particular development environments and modeling tools and who knows what. It is important to have great programming experience and to know different programming paradigms. But these things, you will suck them up as if you have the right attitude. So if you miss this attitude, you will, knowing all these things, you will use them in a wrong way. So it seems that it's much worse to know less, or it is much worse to know more about technologies and techniques than it is not to have the right attitude. And then, when you have this right basis, the starting point, you can be agile. So Lean enables agile, actually. And you will be ready for change. So agile means that you're flexible, that you quickly respond to change, responding to change. But what enables you to act like this is this calmness in this clear, firm basis that you establish. So you know always you can get back home. And then you can make various kinds of excursions here and there, but you know that you can get back home and you know what's stable. And speaking of this, we talked about these two perspectives, what the system is and what the system does. And on one side, you have all these things related to domain knowledge, objects that you identify in the domain, like crucial things there, and you come to this through domain analysis. And on the other side, you have users and their ideas, their mental model, the roles that through which they see those objects of the domain. They're not very much interested in those objects as much as they're interested in the roles that they play. So for what do I use? I'm not very much interested in the product and how it is established in the system, but that it is for me, it is an item that I'm going to buy. I'm not interested very much in what is the underlying structure of the banking system. I'm interested in transferring money from one account to another account or such things. And so I have actually add roles to those objects. And these two perspectives actually again can be with these two perspectives can be distinguished what is more stable. So what the system is the more stable perspective than the ever-changing what the system does perspective. It's more variable. It's not that it is not important, but here we on the left is what is on the left is the basis for what is on the right, not vice versa. When we do not know the domain, of course, we need to go through use cases and analyze what are the possibilities, what the domain actually is, and then pack all these things up into the coherent view of the domain, of course. But mostly we know what the domain is. There are many systems in the domain, many related systems in the domain, to the domain, practical experience in the domain from domain experts. And these things need not be discovered by just, pretending that you're listening about banking systems for the first time. So you come to the bank for which you are developing the information system, and you come and you ask them, okay, what do you actually want? We don't know nothing. We know nothing about banking, but tell us what you want. So it doesn't work like this in most cases. And furthermore, more stable means that we do not want many changes there. So once we decide, and this is like the foundation for the right side, for what the system does, so we do not want to change foundations. Those foundations are not concrete in terms of material, like they're not firm material, so that like in buildings, that you need to destroy them physically and with physical force. But it hurts to change them because so many things depend on them, and so many things will inevitably be changed after changing them. So it's not that you cannot, that they're somewhere buried, and you have to dig for them to get to them and then change them. That's not the problem. The problem are dependencies. And another perspective on this is through commonality and variability. So as I mentioned, what the system does is more like variable. And we talked about software product lines and feature modeling and such things. So when you develop systems, what is the basis? You can follow this on several levels. Certainly, commonality is more about what will remain stable, and variability is more about what is likely to change. And I'll get to software product lines in a moment. But here we have use cases. So I mentioned use cases as belonging to what the system does perspective. And here we have this metaphor of a string and pearls as use cases, as pearls that you can change on this string without decomposing the string. So you don't want to mess with the string too much. Only if you have to, and your string is your lean architecture, and your use cases ideally are as easily added and subtracted as pearls on a string. This is kind of an addition additional emphasis is on this perspective is observable in the DCI approach, the data context interaction approach. So it relies upon this, that use cases are actually the data is the basis, and use cases are actually that variable part, or things that we think or count with changes in them. More than this comes from data analysis. So these are the things that we will know from the domain. So the whole approach is organized around this idea, so that you can actually, as is depicted here in these roles, and this binding, pro forma binding relationship to domain objects, the whole thing is organized so that use cases are decoupled, and not just decoupled, they're very much preserved in the code, and plus they are decoupled from what the data is, or what are those objects that represent more like data entities than process entities. Okay, there might be some processes there as well, and there are some processes very much inherent to the domain, but there are many more things in use cases, and like placing an order is something that might be done in one or the other way, and with variations, and this comes the information how is this being done comes from the user requests. These are the things that will be behind the scenes anyway. So this is what we're talking about, and this is an approach that enables you to it's a technique, and that enables you to achieve this. So if you follow the DCI approach, you will come to this, what you need to maintain, how to make your system more maintainable. And software product lines, which I was impatient to mention, they rely on commonality and variability and their interplay, so that you actually have this process of domain engineering that produces the things that you can pick and choose from. So you actually, what do you do there? You actually anticipate some things. So it is an investment. It might be producing some waste in the end. You anticipate some things that will be requested by your customers, and then you produce your systems easily, because you can put those components, and not just components, but domain-specific languages, generators, or whatever frameworks, components as frameworks, together into one coherent system. Of course, you will always have some custom design to do and some custom implementation, because there will be some unanticipated requests placed as you go. So this is when I think again about software product lines. In the end, if you are not careful, you might produce a lot of waste, because nobody would want those features. Then regarding use cases and how to treat them, there are ways. We'll talk about this in the next lecture, but my last lecture, and actually the last lecture in this course. Then we'll have just a discussion session. Then this is how you can deal with use cases roughly using aspect-oriented programming. You always have, in your use cases, you always have some parts they deal with in your domain objects. I'm not talking about this should go probably through those roles as in DCI, but this roughly speaking, you will end up with some domain objects. But the perspective on these domain objects might be different, as we can see with this order manager that acts differently in place an order and cancel an order use case. This is just a collaboration, a UML symbol for collaboration that I also mentioned in one of the previous lectures, where we discussed advanced capabilities of UML for expressing architecture. So you can put then when you design and you think of your use cases like this, and if you need in the end in normal object-oriented programming, you need to put your order manager as a whole like this. But in aspect-oriented modularization, you could have your order manager for with different perspectives, different versions that you can compose according to some rules that you set. And you can imagine very different, several different perspectives on your classes like this, and you can compose them as needed for different versions of your system. And this is related to like putting your use cases on your architecture string. So when you put a use case there, it's not just that it looks like on that string, in that metaphor, as a kind of bubble independent of other bubbles. Just like here, cancel an order and place an order are like fairly independent bubble, not even a string is there. Okay, we can say that this is a kind of a string. So they are somehow related through the customer with each other. But otherwise, you're looking at them, you see no relationship in this diagram. So actually, use case diagrams are telling lies. Actually, they're a pretty evil thing. Making people think that they are designing something if they put bubbles like this. Okay, I've put them too, but I know what they mean. And to make sure that you know what you mean, usually it's good to write it down. Not to write too much, but at least something, so you should describe your use cases as sequences of steps. And discuss them with your customer. So unless you do that, they are not use cases. And you will certainly forget what you meant by them. So here we can yet another relationship, very interesting. Okay, include relationship is quite a procedural thing, just a procedural call. But this relationship extend, previously called extends in some old versions of UML. The extend relationship means that as this arrow indicates that modify the restock plan affects place and order. And you actually might have an entity in aspect-oriented modularization or programming that affects another entity. So you don't have to modify that entity in order to induce change into that entity. That's what we're going to talk about in more detail in the aspect-oriented modularization lecture. But there is technology for this available, and this technology is available not just in devoted or acclaimed aspect-oriented programming languages. Once there were many of them, many more like academic prototypes or experimental languages, extensions to popular object-oriented languages, but currently, as it goes with the underlying languages development, actually disabled further development of those aspect-oriented extensions, and actually it's more appropriate to talk about languages like Scala even, or Python, or Ruby, or JavaScript, or TypeScript in general, as supporting aspect orientation. So it's not, the idea is not dead and it's available, but it's not, people are not very much aware of it in those language communities. A similar situation is with software product lines. Not so many organizations that maintain software product lines actually know that they do so. And if you know that you do so, there's much of literature that you can rely upon that you're missing, or some experiences or whatever that can help you do those things better. Further thing is to follow how to maintain your code base in good state is to follow object or programming principles in general, but mostly they're like object-oriented programming principles. Here are a few of them known under this acronym of SOLID: Single Responsibility Principle, Open-Closed Principle. That's directly actually related to change. Open-closed principle talks about your code having it needs to be extensible in appropriate way, but closed for changes. So it's you're not making changes to your code, or you're not preparing your code for changes, but to be extensible. And list of substitution principle, that actually if you do not follow it, you will have flawed inheritance hierarchies, interface segregation principles, dependency inversion principles, so on. You can follow these principles, but principles are principles, and they tell you what is that you can recognize that they are being achieved, or that you adhere to them once you see the result. If somebody tells you some principles and tell you, okay, now go and follow these principles, they are not a handbook, a manual on how to do things. There's not much practical instruction in them, or if any, as we can see in patterns, for example. And here's another pattern that we did not include in previous lectures, called visitor, that directly enables you to prepare your code for following the open-closed principle. Visitor, do you know visitor? Roughly. When you look at its code, it might. I'm not going to go into code. You might be kind of puzzled by what's the point, how it works. That's why it's why is it so. you might know about double dispatch. That something is being decided, what is to be done is being decided on the type of two objects. So the message is being dispatched twice. It's called double dispatch. But that's the technological side. The idea is better expressed like this. So the problem is that operations have to be added to the objects of certain classes, but without having to change them as you go. So you do not want to mess with the existing code, but when you need to extend the functionality, you simply add new operations. But actually, in object-oriented programming, this does not work like this unless you use some advanced things like meta-object protocol and interfere with your program as it is being executed. But normally, you cannot change your classes once they are defined. So this is not that I'm saying that that you're going to do this at runtime, but you need to be able to add further chunks of code modularized as operations. And your base class should be prepared to take this into account. And then these can be executed. So the idea is roughly like this, that to implement each operation to be added in a separate class that follows a common interface. And that interface is known to the class to be extended. Make this class entry operation transfer its current object to the class that implement to the classes that implement the operations to be added. Here's this double dispatch in plain words, no programming code. So when you use visitor, you can, or if you don't have visitor implemented, you will not be able to do act in such flexible manner, or so to introduce new kinds of objects. I don't know what I'm showing to my students in object-oriented programming. It's a kind of a game with knights and ogres, or ogres and knights, and there is an example with a knight and a sword, and a knight actually fights with a sword, and it change if the kind of a sword influences on how strong the knight is against ogres. And there can be different kinds of swords, and over time you can have demands to add new types of swords. And if you implement this using visitor, you will transfer the responsibility for the what's called for the hitting an ogre with a sword to the sword, and each sword will know how strong it is and how much energy it takes to the ogre. And so adding, if you implement this using visitor, you will be just adding new classes with new operations that represent these swords. You will not be changing the definition of the knight, nor ogre, nor anything else. You will just be adding these. Okay, you have to put your new swords into function somewhere, but you don't have to change the behavior or a code of the knight class in order to do this. So if you don't have this implemented, the behavior of that game will be the same. Users will not encounter this, but they might request some new kinds of swords over time, and then you will be messing around with lots of things that that should remain like that, because like you don't want to have those if statements, case switch, and such things introduced in your code and changed all the time as new entities are requested, new kinds of entities. And then you can stop for a moment and say, okay, what am I doing? Let's refactor. Let's introduce visitor. And all further changes that will come will go through visitor. So this is something that you can do with many other patterns. So like whatever here, there are listed, some examples are listed here. And actually, POSA 4 did not forget the book POSA 4, Pattern-Oriented Software Architecture by Bushman and colleagues. Did not forget on this, and actually there is a chapter called Patterns for Adaptation and Extension there. And these patterns, I think there are some more patterns related to this, but you can go through these patterns as well. As some other patterns that I will mention here as we go with this lecture. So the first thing that we can observe here is that architectural decisions are not easy to change. Therefore, the architecture should be ready for adaptation and extension as much as it's feasible. So you might implement some things in a more flexible way. Of course, if you are pushed by the budget, by the time, you will not do this directly in the first moment. Simply, you don't have resources to do that, and you're requested to deliver some functionality. So you will make quick and dirty solutions, knowing that you're not doing quite a good thing for the future. And this is called technical debt. Technical debt. So you will owe yourself or the organization to do some things that you missed in the first approximation. Have you heard of this notion? Technical debt. And then you resolve technical debt. Typically, what comes next is this notion of refactoring, which I was impatient to mention. And then how to do refactoring. So I indicated that you can go through patterns. We will get to this, but the thing is, what are the indicators of? It's like it might not be that likely that you will look at your code and say, oh, there is no visitor there. That's bad. There's no strategy there. Maybe you're likely to spot this, but you will spot some other more obvious things, like that you have duplicated code. However, sometimes it might be better to leave it like this for some reasons, but usually you can extract a method or form template method. You can have a long method, although this might be all right many times, but usually you can extract or apply extract method strategy to extract several methods out of your one long method. So probably this long method treats many different things, and then you cannot use it like this in all the occasions that you need these things, and then you can you might duplicate your code because you cannot call a part of your long method. So this goes maybe hand in hand. A large class that you have that involves so many different things, and then you can't use it properly. You can extract class or extract subclass, so you actually build an inheritance hierarchy, or you can, and this is actually by this you're adhering to the single responsibility principle. So we are not going directly into patterns. So these are simple strategies, but Alistair Cockburn said to me once that when I mentioned patterns, what patterns? Those are not patterns, those are just strategies. I still think that might be some, and then we had a longer discussion in which he started using this notion of a pattern, and I think that even that he knows that there's a bit more to patterns than just that they are just strategies. Of course, not just any strategy you would consider a pattern. Maybe we can say it like this. Single responsibility principle is by these two strategies of extracting methods and extracting classes, or extracting subclasses even, so 3 or several, or even form template method, so parameterize things. Actually you add to this principle. Then you have switch statements. Well, not necessarily they are evil, but these are switch statements are a place that is so often being changed. And then you need to open your code and change code, and who knows who relies on that code and so on. So switch statements, you can treat them with polymorphism. Is there anything bad with this? Or with polymorphism in general? You don't really see what's going on when you use polymorphism. You're overriding methods, And in the end, where your methods are being called, you don't really know what code is being executed at that place. So you're giving up this. What you receive in favor is the flexibility of your code and its maintainability. But you might start losing track what's happening. So it's not ideal. And you might even think of using visitor, as I indicated when I was talking about visitor, that I had this case. It was a kind of, maybe it was a if else, but what is if else? It's just like switch statements, so a decision block which was changed completely with or could be replaced by visitor. So you can use visitor here. Then you can have a data class, and this is the strategy of moving a method to it that operates. Move method, I think it's you have a method that operates upon some data class. This data class is kind of rather a dummy class that does not include any extensive processing or sophisticated processing. Object orientation, or some ideas of object orientation are like that. Operations should go with the data they process, but it's not always like that. It's better, and recall a unified process distinguishes between three different kinds of classes. One of them being entities, which is more like data classes, and the other one are control classes that process things, and boundary classes like interface classes or that can be user interface classes or system interface classes. And DCI explicitly claims otherwise. So you should have some classes that are more like data classes. So the opinions are different and the strategies are different. You need to decide for yourself, and not everything is applicable. Like if you take some advice from somewhere and then the other one from elsewhere, they might be contradictory. All these things that are here presented are called bad smells in code. And Fowler and colleagues presented a lot more of these and different ways of resolving these bad smells. So if you have a situation like a large class, then do that. If you have a long method, then do this, and so on. So it's like that. A different way, when we talk about this more advanced thing, using not just using polymorphism, I think Fowler stops here. He does not go very directly to patterns. There is a way to treat these things in a more flexible manner using patterns. So I've just mentioned this, that even Bushman mentions this, but Kiryevsky actually built an approach that is called refactoring to patterns. And it's not that easy just apply a pattern. So it lots of things what Karievsky describes are a lot of things are about how to apply design pattern to existing code. It's no longer, okay, you have an empty file and you start writing your code and you apply your pattern there. You have your code, but you need to refactor it to change it so that it follows a particular pattern. And that example of introducing visitor, actually I'm doing this exercise myself with students. I actually doing, well, we discuss the possibilities and have some voting and some such things, so they are involved in this. And actually this is refactoring to visitor, what I'm applying according to Karievsky. I'm not sure I'm following completely his steps, but roughly it is so. The other things is that these steps themselves are not that trivial. So they're more like what Fowler talks about. So this is a whole lot another level of complexity. And this is something to think about. Applying individual patterns here and there, is there any problem with that? Plus that when you apply visitor, if polymorphism introduces complexity to your code, what do you think visitor would do? But your code it would be a whole lot more complex after applying visitor. Does it pay off to apply it? So you need to decide. And things might get worse. So you're looking for flexibility in your code and you're applying things to introduce this, but these things are so complex that no one is capable, at least in your organization, your colleague programmers, they're not capable of understanding this or nor willing to deal with this. Then just let them copy-paste code. That will at least work. Maybe so puzzled by some things there that they will be enabled in a reasonable time to find their way out. So you will be late with your change requests in the end. So that's one issue for certain. And let's get back to this one, applying individual patterns here and there. Any problem with that? Well, we know about the whole pattern approach is based on the idea that patterns are adding something to the whole, and they do this coherently. So when you apply one pattern here and another there, this might not be so coherent. Maybe actually might be contradicting to each other, and that's why Gang of 4 patterns are being heavily criticized for this, for not forming a coherent system, not forming a pattern language. So if you follow a pattern language, so because you might be spoiling your whole. If you apply them in a system, then patterns, then you see how they resolve some conflicts of forces and what conflicts do they open, and what other patterns you need to engage in order to treat these conflicts. So if you do that, then you should take into account this advice. So similarly, when refactoring the design of an existing distributed application, you enter the language via the particular pattern that addresses the problem whose current design is subject to refactoring and continue from there. So if you can, you should not stop by implementing just or putting there some one pattern. You should push this through to the other patterns from that point. You cannot maybe change completely the environment that you live in, but you can build a better house. Maybe you cannot build a better house for you because you don't have enough funds for this, and your house is already there, or your apartment. But you can do some things from that point there that are changeable from your perspective and affordable to you. But you won't stop at that point. You will go through all the patterns that follow this. So these are like treating further details, not treating the context. So you cannot change the context. That's given. But you should propagate things through that sequence of patterns that follows from that pattern that you applied or have applied. So this is one such example, maybe, that we can have a look at roughly. So this is a client dispatcher server and forwarder receiver patterns, or what is it? Oh no, sorry, I mixed it up. I thought I've put some example of this here, but it isn't so. This is yet another level to think of patterns. What Bushman and colleagues say here is that they're explaining how in POSA 1 there were some patterns missing there, or actually existing there, but then they were omitted because they are better covered by other patterns, and they also revealed that these patterns were too broad in scope, which suggested refactoring the patterns into multiple smaller, more focused patterns. The responsibilities of client dispatcher server are thus addressed by broker, which we know, configuration that uses a lookup, we did not talk about that pattern, and client request handler, not that much, server request handler, and forms a forwarder receiver, and this forms this forwarder receiver arrangement of patterns. So roughly what they did is that they decomposed something they formerly considered to be a pattern into several patterns, into a small pattern language or pattern sub-language, or a generically applicable pattern sequence. And this is yet another yet another refactoring, and they actually use this notion of refactoring. Refactoring that we can apply. So if we think in patterns and if we do our things in patterns, inevitably we will come to such situations. So if we use patterns extensively, so we will refactor some patterns like this. And this is a kind of a meta level in refactoring. So we are actually refactoring our, so to say, refactoring techniques. Some of those patterns might be too big to be applied like this. And when we refactor them, maybe some other things will come into play, and we will see how these patterns can be, how they are related to other patterns. In our research of patterns, mainly organizational patterns, so patterns of people, we're constantly looking for additional relationships between patterns. So some relationships are indicated in the literature or by those who initially encountered and expressed these patterns in writing. But there are some implications and some indications in practice and practical use of those patterns that reveal that they can be combined in different ways. Not even Alexander, he never said that you should follow blindly his pattern language for building architecture. Actually, was explicit that you should create your own pattern language and then stick to it or maintain it. So choose the patterns that you need, add the missing patterns, and then use these patterns as you go, like this. The same in software architecture. So I mentioned already people. We talked about Conway's law. And this is not it exactly. This is Conway's law restated for today's lecture on maintaining software architecture. So you know that Conway's law talks about or is an observation of how organizing people translates into software systems. So how you organize people, how you organize communication paths between people, this will be reflected in the system they develop. It's just a logical consequence. People are simply reflected in the code they develop. And from the maintenance perspective, we can say that a difficult to maintain software architecture might be generated by inappropriate communication links in the organization. So maybe it's not just that you need to refactor your code. You need to refactor your organization. You need to apply appropriate, and how do you do that? Again, you can use patterns, but not design patterns. You can use, or you should use, organizational patterns. your organization is already established, and it needs to work, it needs to function, to produce something, and it is producing something, and yet in the middle of it you need to refactor it. So it's a challenge to do that without pissing the people too much. So it is then the kind of the art of introducing piece by piece different organizational patterns that will help your organization improve its internal communication links. So this is actually, why do I have this here? Yet another thing. I guess this was not meant to be connected to organizational patterns. So this is one thing. I wanted to end with this, but I see that I missed this slide elsewhere. I was wondering where it was. When we talked about software product lines. So I thought, okay, let's forget about it. But this is also about how you organize software development. That's why it is placed here. So software product lines, the scheme that I showed to you, how that approach works, is about how you organize producing, or how you produce, how you organize producing your, how you produce your code, how your code is organized in the end. It is organized into composable chunks of some kind, and into the means of needed for that composition, and into generators that will generate your application out of those composable parts or configurable parts. Or if you have your feature model somehow expressed and attached those features through maybe some annotations, Jakub could tell about this, that you can switch off and switch on, and you can configure the code that you produced by this. This is what I was talking about with that scheme. But here this is something else. This is how, and I showed you this previously. But now my intention is to point out that this is also related to how you to maintenance. So software product lines can come out of maintenance efforts. Not always. So this is this possibility where it does not happen. If you introduce your software product line revolutionary, so at once, and with no product base. So we get together and we say, okay, we have some spare time, and we will establish the software product line and develop software systems for our customers in a cheap way, and then get some big money out of that. But now we need to kind of spend half a year developing the components and everything else. Is there refactoring there or something like that? No. What are you maintaining? Nothing. Nothing to maintain. But in all other cases, actually, maybe even this one, but let's see this existing product base. With existing product base, you have something to refactor, and you do that in order to get to your software product line. Either you stop, okay, you say we have enough products and now we will spend a few months or even that half a year or a year or whatever time to get a software product line right out of that. We will refactor many things. So we are doing maintenance. Maybe we will not change the behavior, but it's likely that we are going to change some things because we'll be improving things. But anyway, we will have to completely reorganize things so that we can produce systems on demand. And the same here, but you do not stop your development. So it's in a way it's even worse because you're developing software systems, and you need to consider even those new not yet finished software system that you're going you need to deliver soon, and incorporate it into your software product line. That's clear that you're doing maintenance here for the sake of establishing a software product line. Here with this one it's gradual development of a product line during which products are being delivered. So it happens to be maintenance again involved here because you are not stopping you do not stop delivering your products, and they have to be considered for your software product line. So some refactoring must be involved there because you refactor them and you put their components into your product line. So this is a highly unlikely possibility for establishing software product lines. I think I don't have to explain this very much. So all these possibilities all these things are possible even if people do not know about software product lines. Maybe even this one, but usually you need to either you have something and you have some time to spend on putting decoupling things and establishing software product line, or you do establish your reusability base as you go. You might not call it a product line, but it will be in the end a product line. And roughly that's it, what I wanted to tell you today. So this other thing that we have here is that the architecture can be made more adaptive and extensible by refactoring at different levels, including people. Lots of things, lots of techniques, lots of possibilities to study. I could easily take Kirievsky refactoring patterns or strategies or even Bushman's patterns that are intended for that. I actually have shown the list of those patterns, and then include and then ask questions at the exam like this, that okay, tell me, explain me this pattern and that pattern, but that's not the point. You will take these things and you will study them and you will apply them as you go, but the thing is that you need to know the strategies, higher level strategies for their application. So please do go on and have a look at the literature, not just related to this lecture, but to other lectures as well, and make your own opinion on these things. So the point is not to learn these things and to know how to repeat quickly and draw some diagrams or patterns, but the point is to know how to talk about them, and for this you need to to see some of them, not just in this way that I'm showing them to you in this short time, although you might consider these lectures to be too long, maybe. They're too short to go through all these and to learn these techniques and patterns and so on, so that you can apply them. So I've gone through this, but everyone needs to go through this on their own. So you might study some other parts that I studied. That's fine. The project and the exam are organized in such a way that whatever you do, if you invest some time into this, you are going to be successful in that. But this does not mean that you don't have to do anything with this, apart from following the lectures and doing the minimum of the project. Okay, so that's it. We can talk about the exam at the final lecture as well. The next time we will have the guest lecture. Thank you for your attention. I did not ask whether there are any questions, final plenary questions. Sorry for that. No, individually, if you would have any questions, please do approach me. Thank you for coming and thank you for your attention. See you next time. Yeah, I was waiting for that. Thank you.